Okay, so today's lesson we're going to be continuing our conditional probability ELR on 13.5. So today's lesson should be a review. We're going to do many questions together, see if you can get these answers, taking notes, and then you'll be putting your notes on Google Classroom since I am not here today. Okay, so here is the warm-up. Hopefully you did it with the substitute that was there, but let's go over this just in case. So here's this table of sophomores and juniors playing varsity versus non-varsity sports. And they're asking us these three questions on the left. That capital P means probability. So let's see if we can find out the probability of a person being a sophomore and on a varsity team. So if we take a look, being a sophomore and on the varsity team, there are three of them out of the total of this whole table, which is 30 students. And you can reduce that if you like to 1/10. The next one there, sophomore, and it has this slash, and this slash means that given. So you find the probability that this person is a sophomore given they are on the non-varsity team. So this is the one that we were talking about in last class. This is the one where we're going to be using the conditional probability formula here below. So I'm going to actually follow it exactly. So A and B, we have it as sophomore and non-varsity. Sophomore and non-varsity. All divided by the probability of the event that comes after the slash, which here in the formula is A, is the probability that they're on the non-varsity team. So once you have your formula set up, we need to locate these two numbers on the chart. So let us take a look here. We have sophomore and on the non-varsity team. That is right here. There are 14 of them. And total on the non-varsity team is 19. So the answer for number 2 is 14 over 19. All right, for number 3 here, we're looking for the probability of junior given varsity team. So if I follow the formula for conditional probability, I want to find the probability that they are a junior and on the varsity team. And in the denominator would be what comes after the slash, which is the probability of varsity. So now we're going to go up and take a look at our table here. Okay, junior and on varsity team, there are 8 of them. Total on varsity team is 11. So the answer for the last part of this question is 8/11. And that's what I have here on this next slide. It gives you those 3 answers that we just went through together. All right, so today's objective is reviewing the stuff that we've done so far. I will be getting into something a little bit different today and also when I get back on next week with tree diagrams. So today's agenda is looking at this video, taking notes, then submitting a copy of your notes on Google Classroom before you leave today. Once you have done that, you'll be working on that thing on Google Classroom, practice with conditional probability. The answers are also online and they are also will be up on the front board if you want to check. Once you have done both of those things, that's when you complete that Google form quiz on all these ELRs. If you don't do well on this quiz, you may go ahead and repeat and do it again. So let's get started with some practice questions here. All right, so here's a table of grades of middle school students in a math class, and they are asking us different questions. So, males versus females, grades A, B, C, D, and F. So the first question is asking, what is the probability that a randomly selected student got an A or B? So, A or B, well, I see a couple of students. We have A or B. We got these for the males and these for the females. So I need to add those up. So I'm getting 48 of those out of the total amount of students, 100. So that's the answer for number 1. Number 2, what is the probability that an A student is a male? An A student is a male. So how many males have A's? 17. again, out of the total of the whole population there, 100. Okay, number 3. What is the probability that if a student was female, that they got a passing grade? So a passing grade is the grades A, B, and C. D and F are not passing grades, even though we don't have D's at peak to peak. So A, B, and C are passing grades. So how many females got a passing grade there? So if we take a look, females that got a passing grade, 12, 11, and 13. So there's 36 of them out of the total population of 100. Okay, let's look at the next one, number 4. What is the probability of a male student given that they failed? So because of the word given, we're going to be using the conditional probability formula, just like we did at the warm-up. So I need to find the probability that this person is male and they failed a class, divided by the probability failed. So remember what I said. You are failing if you have a D and an F. So looking at the table here, male and they failed are 11 of them plus 3. So that's 14 of them. Out of the total of everyone that failed, which are these two columns here added up, D's and F's, 17 plus 8 is 25. So that is the answer for number 4. Okay, let's move it on. Last question there, number 5. What is the probability of a randomly selected student got a passing grade? So any random student got a passing grade. So a passing grade are A, B's, and C's. So we have all of these, right? So I'm just going to look at the total here, 29, 19, and 27. So that's 75 students that got a passing grade out of the total of 100. All right. Okay, here is a question that I'm going to be asking you questions about and also doing a sample space, a tree diagram. And we're going to be doing a lot more of these next week also. So a family has two children. Assuming males and females are equally likely, determine the following probability. There are the 3 questions. Let's make a sample space to show the possibilities first. Well, for the first child, you have a probability of boy or girl. For the second child, we could have, if they had a boy, they could have a girl, or they could have a boy for the second child. If they had a girl first, they could have a boy second, or another girl for their second child. So right now, we have a total possibilities of how many? We got 1 here, 2, 3, 4 different combinations of either boy or girl, first and second child. And on this next slide here, I show it to you, and I also show it to you as a sample space here. If I was not to do a tree diagram, here are the 4 possibilities. All right, so let's go and take a look at those 3 questions now. I have the answers here, but let's talk about them and see if we can see them. So what's the probability that 1 male and 1 female, given the first child is a male? Because, again, it has that word given, we know we're doing the conditional probability formula. So we need to do the probability of a boy and a girl, that they are male, and that the first child is a male, is a boy, because that's the denominator. So if we take a look at the tree diagram or those 4 things here below in the sample space there, probability of a boy and a girl, given that the first child is a boy, well, there is only 1 possibility, which is right there. And then in the denominator, the probability that the first is a boy, well, I see 2 of them, 1, 2. So it's a half for number 1. All right, let's try the second one here. Oops. All right, the second one says 2 girls given, again, here's given, that at least 1 is a girl. So I want to do the probability of 2 girls and at least 1 girl on the top divided by the probability of at least 1 girl on the bottom. Okay, so the probability of at least 2 girls, 1 of them a girl, well, there's only 1 possibility, which is here. Out of the probability of at least 1 girl, we have 1, 2, 3. So the second answer is 1/3. Okay, last question. what's the probability that 2 girls given the older one is a girl? So again, it's got the given. So I need to do conditional probability. So I'm doing what's the probability of 2 girls and the older one is a girl divided by the probability of older is a girl. So 2 girls, older is a girl. Well, here's just one spot right here, girl, divided by older is a girl. Well, here's got this one and this one, 1 and 2. So 1 out of 2 would be the answer for the third one. Okay, let's look at this table. I'd like you to read it. Try those 3 answers and see if you have the correct answers. Unpause it and see if you're getting it right. Okay, so for number 1, conditional probability. So you're looking for probability satisfied and had knee surgery over how many had knee surgery. So on the table there, satisfied and knee surgery was 70. Out of the total that had knee surgery, 95. Okay, for number 2, you're doing conditional again because a given. Probability of knee and dissatisfied, all divided by those that are dissatisfied. So knee and dissatisfied, there were 25. And then those that are total dissatisfied was out of the 40 people. Okay, last question again is the given. So it's a conditional probability question. Probability of dissatisfied and had hip surgery, which was, let's see, dissatisfied and hip surgery was 15 of them. Out of how many had hip surgery, which was 105. Okay, so let's go back, review permutations and combinations. I have 4 scenarios here. All I want you to do is tell me if it's a permutation or a combination, P or C, for your notes. So take a look at these, decide what you think they are, and then come back to get your answer. Okay, so here are your answers. Number 1 is definitely a permutation because they're choosing positions captain and co-captain for order. Number 2, they're deciding to choose 9 countries from the 13. No order for that one. That's a combination. The third one there, because they need a batting order of the 7 players, that is, again, order is important, permutation. And the last one, number 4, choosing applicants there for a computer programming position. There is no order there from the 45. It's a combination. Okay, here's a review of the 13.4 ELR when we have compound events versus independent versus dependent events there and overlapping. You should have these in your notes, but I wanted to kind of go through them again for you here. So independent events, these are events that are totally separate from each other. They can't happen at the same time. So to get this answer, you're going to be adding the probabilities together. So if I'm rolling a die and flipping a coin, those have nothing to do with each other. You'd find both and add them up. If you have probability of overlapping events that are going to happen at the same time, and let's say there is an intersection of these overlapping events. Examples we did in class was rolling die, rolling an odd number and a 3. Because 3 is odd, you would subtract that overlap there. It has the word or in the problem, and this was the formula that you would use for that. If you had more than one event, and they're not related to each other here, you're going to be multiplying these events, and depending on if it's replacing or not replacing, you will be decreasing the denominator by 1 there. Okay, so let's take a look at some questions. Here's a spinner. Let's see if you could answer these 5 questions on the left. You could pause the video and come back to see if you have the right answer. Okay, so here are the answers on the left for number 7, 8, 9, 10, and 11 there. There were some overlapping things for 7 and 8 and 11. So hopefully you got those 5 right. Okay, last bit of stuff for your notes today. Here's A and B. Again, read these questions, pause the video, come back and see if you're getting the correct answer. Okay, here you go. A, you got 3/10 times 3/10 because he puts the marbles back, so the denominator is going to stay the same, 9 out of 100. And part B there, the fruit will decrease because John does not put his fruit back. So 4/9 out of 5/8, 20/72. So that was a review of everything we've done so far, just a quick thing. So what your agenda is for now is to take a picture of these notes that you took and put that on Google Classroom so that I know that you watched this video and did the notes. After you've done that, you'll be working on a conditional probability practice. So take a look at that online, practice that. The answer key will be on the front board and also there in Google Classroom. Just be careful. And then when you're done with 1 and 2 above, there is a Google Form quiz that has a link on Google Classroom on these 5 ELRs. If for some reason you don't like your score that you got, you may go ahead and retake it again, and you may use your notes. Thank you all. I will see you next class, and have a good rest of your day.